Hello my dear students, welcome to my YouTube channel that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today I'm going to teach you the topic the photoelectric effect. In photoelectric effect, first of all let us understand some simple terms. First of all, in case of metals, let's talk about metals. In metals, the electrons are very loosely bound by the nuclei and they are almost free to move. So when a high energy photon strikes that electron of metal atom, the photon will impart all its energy to the electron, which will cause the ejection of electron from metal atom or a metal surface. This phenomenon is called the photoelectric effect. So I'm writing for you. In metals, in metals, the electrons are very loosely bound by the nuclei. And they are almost free to move, and they are almost free to move. So when a high energy photon, I'm writing, so when a high energy photon strikes that electron, when a high energy photon strikes that electron, comma, the photon will impart its whole energy to that electron, which will cause ejection of electron, ejection of electron from metal atom, or you can say metal surface or metal surface. This phenomenon is termed as photoelectric effect. This phenomenon, this whole phenomenon is termed as photoelectric effect. Now, this effect supports the particle nature of photon. Particle nature of photon. So now let us understand this concept diagrammatically. Assume this is the metal surface. What will happen when a high energy photon come and strikes the metal surface? That's a high energy photon. When this photon strikes the metal surface, it will impart whole its energy to the electrons of metal, due to which what will happen? The electron will be ejected from the surface of metal. That's called photoelectric effect. Here I am writing ejection of electron from metal surface when a high energy photon strikes it. That's called photoelectric effect. So now let's talk about some more terms which we are going to use in this topic. Now, the minimum energy of a photon must possess to eject electron out from the metal surface. That's called the work function of that metal atom. So minimum energy required by a photon to eject electron from metal surface, where I'm writing the minimum energy that a photon must possess. The minimum energy that a photon must possess for ejecting out electron from metal surface is called work function of that metal atom, is called work function of that metal atom. I hope you got this point. The minimum energy that a photon must possess for ejecting out the electron from metal surface is called the work function of that metal atom. Now, work function. Work function is represented by a symbol phi. And it is the minimum energy of photon to cause photoelectric effect. And you know that the energy of photon has a formula which is equal to the h nu, where nu is the frequency. Now h is a constant term, so here you can write nu naught. Nu naught will be termed as threshold frequency. Now h nu naught, what's the formula of frequency? Is c upon lambda. Now mark it as a lambda naught, because h and c are constant terms, so we have to write the lambda naught. That's called threshold wavelength. So now let's talk about it. What is nu naught? The nu naught is called threshold frequency. What is threshold frequency? Now, energy of a photon is directly proportional to the frequency. So it is the minimum frequency that a photon must possess to eject electron from metal surface. So what is threshold frequency? The nu naught. What is threshold frequency? It is the minimum frequency. It is the minimum frequency that a photon must possess to eject electron from metal surface. Now let's talk about the threshold wavelength, the lambda naught. This lambda naught is called threshold wavelength. Now, the energy of a photon or you can say the work function, is inversely proportional to the wavelength. So threshold wavelength will be the maximum wavelength required by a photon to cause the photoelectric effect. So what is the threshold wavelength? It is the maximum wavelength. It is the maximum wavelength that a photon must possess to eject electron from metal surface. So that's all about the work function. What is work function? It is the minimum energy that a photon must possess to cause photoelectric effect. What's the formula for energy of photon? It's h nu. So here I have written h nu naught, where nu naught is the threshold frequency. The energy of photon is directly proportional to the frequency. It is the minimum energy required by photon, so it will be the minimum frequency that a photon must possess to eject electron from metal surface. On the other hand, the threshold wavelength. Now energy of photon is inversely proportional to wavelength. We require the minimum energy of photon, so wavelength will be the maximum as of the inverse proportionality. So it is the maximum wavelength that a photon must possess to eject electron from metal surface. Now let's talk about next topic. If photon is having energy higher than the work function of metal, then that extra energy of photon will be imparted to electron as the kinetic energy of the electron. So I am writing, if a incident photon has energy greater than the work function of the metal. If the incident photon has energy greater than the work function of the metal, then the extra energy of photon will be imparted as kinetic energy of the electron. Will be more specifically you can write, will be imparted to electron as the kinetic energy of the electron, as the kinetic energy of electron. So here what I have written, if an incident photon has an energy greater than the work function of the metal, then the extra energy of the photon will be imparted to electron as the kinetic energy of the electron. So I am writing, if the energy of photon is greater than the work function of the metal, then the rest energy of the photon will be imparted to electron as its kinetic energy. So energy of photon will be equal to the phi plus kinetic energy of the electron. Here I am writing maximum because after ejecting, the electron will have the maximum kinetic energy that have been given by the photon. So I have written maximum word. So energy of photon will be equal to the phi plus kinetic energy maximum. So it is maximum kinetic energy that electron will require after ejection, and that will be equal to the extra energy which the photon is having other than the work function. So now what next? Now the energy of photon will be equal to the h nu. The phi is h nu naught plus kinetic energy of electron. Or you can also write h c by lambda is equal to the h c by lambda naught plus kinetic energy of electron. So now let's talk about the graphical representation of photoelectric effect. Now I am teaching you the graphical representation of photoelectric effect. Graphical representation of photoelectric effect. So now what formula we were having from above? It is h nu is equal to the h nu naught plus kinetic energy of electron, or you can rearrange it like nu is equal to the nu naught plus 1 by h into kinetic energy of electron. Now just compare this equation with y is equal to c plus mx. So now I'm making the graph. Now this is the y-axis, this is the x-axis. Now on y-axis what we are having, just compare it. On y-axis we will be having frequency. On y-axis I am taking frequency, that is nu. On x-axis what we are having? We are having kinetic energy. So on x-axis I am taking kinetic energy. So now what's the intercept? The intercept is nu naught. That means we are having a positive intercept. This graph will not start from origin. It will start from the certain point which is on the positive axis of y-axis. So this is the intercept. From this dot the graph will start. Now what's the slope? The slope is plus 1 by h. The slope is in positive, so this graph will go like this in upward direction because of positive slope. So here slope comes out to be plus 1 by h, and here the intercept is c. That means this graph is starting from the positive y-axis, not from the origin. So the distance of that point from where the graph is starting from the origin is called intercept, which is represented by c. It is equal to the threshold frequency, the nu naught. Here the slope is m, which is plus 1 by h, which is, hold on, plus 1 by h. So this is the graphical representation of photoelectric effect. I hope you got all this thing. Now let me make 3 different cases for the photoelectric effect. Now I am talking about the case number 1. Now let's talk about case number 1. When the energy of incident photon is less than work function. When the energy of incident photon is less than work function, then no photoelectric effect will occur. No photoelectric effect will occur. Now the case number 2. Case number 2 is when the energy of incident photon is just only equal to the work function, then the electron will get ejected out. The electron will get ejected out from the metal surface, but with zero kinetic energy after ejection. Zero kinetic energy after ejection. Now let's talk about the case number 3. The case number 3. If the energy of photon is greater than work function, then ejected electron will surely get ejected out. Electron will get ejected out, but will also have kinetic energy after ejection. So that is, the energy of photon will be equal to the work function plus kinetic energy of electron. So that's the 3 cases. Now the further subtopic is photoelectric current. Now let's talk about photoelectric current. Photoelectric current. It is a number of photoelectrons passing through a given cross-sectional area in a unit time. That stands for photoelectric current. It is the number of photoelectrons. It is the number of photoelectrons passing through a given cross-sectional area in a unit time is called photoelectric current. Now, number of photoelectrons ejected. Here I am writing number of photoelectrons ejected is directly proportional to the number of photons falling on the metal surface. It is directly proportional to the number of photons falling on metal surface. Now, the number of photons that are falling on metal surface, or exactly the number of photons, is called the intensity of light. It is called intensity of incident light. More the intensity of incident light, more the number of photons will fall on the metal surface, more the photoelectrons will get ejected out, so more will be the photoelectric current. So I hope you got the meaning of intensity. It is the number of photons falling on the metal surface. So now my next topic is stopping potential. So now let's talk about stopping potential. I'm writing stopping potential. For stopping potential, I have to firstly make a circuit diagram, and it is like this is cathode over here and this is anode over here. The cathode, anode. This is my circuit. This is my battery. Now, what will happen? Photon. The photon will be incident on this anode. Here, the photon is incident over here. What will happen? The electron will ejected out from this anode surface or the metal surface and will start traveling towards the cathode. Now, what we have done? We have just joined the battery in the reverse direction to the flow of photoelectron. The battery or the voltage I am writing. This battery, or you can say potential, is applied in the direction in the direction opposite to the flow of photoelectrons. So what will happen? From battery, the electron will travel in this direction. So there will be the emission of cathode rays and that cathode rays will travel towards the anode. Now cathode rays are also made up of electron. It is also a photoelectron. So there will be repulsive forces between the photoelectron and the cathode rays. So here the question is, how much voltage is applied over here to stop the photoelectron? That's called stopping potential. So here I'm writing the minimum potential that must be applied the minimum potential that must be applied to stop the movement of photoelectrons, to stop the movement of photoelectrons. That means I have to stop this movement. Is called stopping potential. Now we have just stopped the photoelectron, but we haven't prevented its ejection from metal surface. So this stopping potential will be equal to the kinetic energy of photoelectrons. So this was my topic for today. I hope you got all the points that I have taught in this lecture. In the next lecture, we are going to solve the numericals on the photoelectric effect. I hope you all understood today's lecture. If any student wants to book a paid online one-to-one class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please like, subscribe and share my channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.